right. Let's see. We're choosing a young adult at random. The probability the person did not complete high school is 13%. 29% that they have a high school diploma and no other education. And 30% that they have at least a bachelor's degree. Okay, so let's make a probability model here. So we've got no high school. And then we've got high school and no education. Okay, so high school only. And then the next one we've got is at least a bachelor's degree. Okay, so bachelor's. Well, we're missing a category here, and this would be some college. Right? So we've got no high school is 13%. High school only is, and no further education is 29%. And a bachelor's degree is 30%. Okay, I just read somewhere recently that the most current data is actually 34% of the population has a bachelor's degree currently. Um, so we've got no high school only, bachelor's degree. So this covers all the possibles. This is at least a bachelor's, right? This is at least. This covers all possible possibilities here, right? Of education. So they have to add up to 1. So since this is 30 plus 29 is 59 plus 13 is 59, 62, 72. Adding up to 100, that would make this 28%. So A, what's the probability that a randomly chosen young adult has some education beyond high school but not a bachelor's degree? 28%. B, what's the probability that a randomly chosen young adult has at least a high school education? At least high school means high school or more. Would be 29% plus 28% plus 30%. Now you can add those up, or you can take 13 and subtract it from 100, which is 87%. They're both the same number, but you can handle it either way, right? Either add up all three of these, or take that and take it away from 100, because all of those have to add up to 100%, right? All right, let's do 35. 35, foreign language studies. Students choose a student in grades 9 to 12 and ask if he or she is studying a language other than English. So 26 are Spanish, 9 French, 3 German, 3% all the other languages, 3%. And none, 59% are studying no other foreign language. Why is this a legitimate probability model? Well, to be a legitimate probability model, okay, each probability has to be between 0 and 1, and the total has to be equal to 1, right? And we can't have any overlap in the categories. Okay, which we don't. And do these all add up? They're all between 0 and 1, and do they add up to 1? 26 plus 9 is 35, plus 6 is 41, plus 59 is in fact 100. So that's why so all of these are met, right? What's the probability that a randomly chosen student is studying any language other than English? So other than English would be all of those. Well, I can add all those up, or I can say it's not 59, so it's got to be all of these must be 41, right? Do you see how that works? You can add those up, which is 26 and 9 and 3 and 3, or I can just do 59, 1 minus 59 is of course 41%. Okay, so this would be 41%. And what's the probability that a randomly chosen student is studying French, German, or Spanish? French, German, or Spanish is going to be 26 plus 9 plus 3, which is 35, plus 3 is 38%. All right. And we're going to learn coming up that the way we write that mathematically is probability of French or German or Spanish. So we've actually talked about this notation in class. Probability of that equals 38%. Okay, 37. We are on a roll. Drawing cards. You're about to draw a card at random from 7 cards. Here's the 7 cards. What's the probability you draw a 9? So probability of drawing a 9. Well, how many 9s are there? 1, 2, 3. 3 out of 7. Right? Probably draw a red 9. Well, of the 7 cards, how many are red 9s? 2 out of 7. And what's the probability that we do not draw a 7? So the complement of 7. Anything but a 7. Well, 1, 2, 3, 4, 5. There's 2 7s, so 5 of them are not 7s. Okay, there we go. Let's do 38 and 39. There are many ways to produce crooked dice. To load a die so that 6 comes up too often and 1, which is opposite to 6, comes up too seldom, add a bit of lead to the filling of the spot on the 1 face. So that makes this 1 go down. If a die is loaded so that a 6 comes up with a probability of 0.2, what are the probabilities of the others, or the probabilities of the others are not affected? What's the assignment of all 6 faces? Okay, so this is what we roll. 1, 2, 3, 4, 5, 6, and I got the probability. And they said the probability of rolling a 6 is 0.2. Okay. And a 6 comes up 0.2. The probability is 2, 3, 4, and 5 are not affected. So the normal probability of a 2, 3, 4, 5 is 1/6. Okay, so if I write that as a decimal, what is 1/6 as a decimal? Since I want to be consistent, either write all decimals or all fractions. Ooh, that's not a nice decimal. It's 0.16667. So instead, I'm going to write this as 1/6, 1/6, because I want to be exact. 1/6, and 0.2 is actually 2 out of 10, 2/10, or 1/5. So then I have to figure out what fraction that is. So I have to add up all these fractions and then figure out what 1 has to be so that they all add up to 1. So this is 1/6, 2/6, 3/6, 4/6. That's these guys. Plus 1/5. Let's add those fractions together. I know you guys love adding fractions. Piece of cake. Common denominator is 30. So I'm going to multiply that by 5 over 5. And multiply this one by 6. So that's 20 over 30. Plus 6 over 30 is 26 over 30. So this whole side right here is 26 over 30. Well, that's this. So this 1 must be the balance, which is, alright, is 4 out of 30 up here. And if I reduce 4 out of 30, divided by 2 is 2 out of 15. So the probability of rolling a 1 will be 2 out of 15. Okay, does that make sense? We're using the idea here that this plus all of these has to add up to 1. Okay, and lastly, 39. A party gives a door prize to one guest chosen at random. There's 48 men, 42 women. What's the probability that the prize goes to a woman? Explain how you arrived at your answer. Well, there's 42 women. And how many people at the party altogether? Looks like there's 48 plus 42 is 90 total. So the probability that you get a woman, or you randomly select a woman, that'd be 42 women out of 90 total. Okay, which we could leave as a fraction, or we can just divide and get 42 divided by 90 and get 46.7%. Okay, and that's because we know there's 90 total people at the party. Alright, there you have it.